Okay, how's everybody doing? So, can you guys hear me okay without a mic?
Yeah.
All right. I'm used to talking to very large audiences in total darkness. So I'm not used to seeing people's eyes looking at me. I may have met many of you already out under the dark skies, and I will not recognize your face, but I will probably recognize your voice. So keep that in mind. Also, if we do questions later, keep in mind that I don't hear very well, so you're going to have to speak a little loud for me to pick up what you're saying. I'm a lip reader, and reading lips in the dark is definitely a new challenge that I've been mastering. So here are some of the images that myself and some of the other astronomers have captured at the Frosty-Drew Observatory. And it really is quite a fantastic place to be to see that night sky. So I grew up, unlike Bill, who grew up in Vermont, I did live in Vermont for a little while. I grew up right outside of Manhattan. And I did not see the Milky Way until I was an adult. And I never looked up at the sky where I was a kid and sat there inspired by what I saw. In fact, I found it kind of annoying to look at the sky because it was just orange. It's like 2 or 3 stars. The first time I visited Frosty-Drew Observatory was when I first moved to Rhode Island in the early 2000s. And my partner took me to the observatory because I was a little depressed about leaving Vermont. And when I saw the sky there, I was like, why is no one talking about this? Because it's so amazing. So at Frosty-Drew, the dark sky is our go-to. It is the core of our program. That image right there was actually in 2020 during the lockdown when only the astronomers and the cops were allowed in the park. And the sky was so fantastic. There was no planes. There was nothing. But it was creepy, though, because like in the park, there was no people either. And there was this swing during like the evening hours, just creaking in the playground. And it totally brought me to like post-apocalyptic video games. So the biggest program that we do at Frosty-Drew is our Stargazing Nights program. Now, our Stargazing Nights event runs every Friday, year-round. Summertime brings more telescopes, it brings more astronomers, it brings our interns, and it brings a lot of presentations from different people that are involved in astronomy in the region. This summer, we're largely focused on the James Webb Space Telescope. Those images have started to come in, they're fantastic. And at Frosty-Drew, we're one of the release locations for new data from the James Webb. And starting this Friday, we're going to have a NASA Solar System ambassador who lives in Richmond is going to be presenting pretty much weekly about the new data coming in from James Webb and what the James Webb means for us from a perspective of science. And our Stargazing Nights at Frosty-Drew are free. They do require tickets so we can manage the amount of people that come out, but the tickets don't cost anything. We started doing tickets because when I first took over the observatory, we were seeing about 25 to 50 people a night in the middle of summer during our peak season. Just before the pandemic, we started seeing about 700 people a night. And it became very difficult. And the theme, hands down, is dark skies. That's what people want to see. You'll notice that it's red in the dome. We use red lighting to reduce the effects that lights have on our eyes so we can maintain our ability to see in the dark, which is really important. It's called dark sky adaptation. And it takes about 15 to 20 minutes to become fully adapted to be able to see the night sky and the landscape around you. When visitors first come into the room and they just get out of their car, they ask if we could brighten the lights up because it's hard for them to see. But after they're in the room for 15 minutes, they're like, can you turn those red lights off? It is so bright in here. And it's a good example of that difference. In 2018, I sat down with one of our board members and I said, let's think tank a new event that we can do. And he said, well, what's our biggest question we get? And I said, have you seen aliens? And he was like, well, we're not doing that. And the next question was, how do I see the Milky Way? Can I see the Milky Way? Where's the Milky Way? So we designed an event called Celebrate the Milky Way. We run it June through August, and we host it on a Saturday night, 1 or 2 Saturday nights per month, that we think will give visitors the best view of the Milky Way from Charlestown. And it's mind-blowing. People come out, and if we don't ticket the event, we'll have hundreds of people out there. People set up blankets in the grass. They'll lay out, even after we close up at like 12:30 in the morning. People will stick around until the sun starts coming in. It's hands down our most popular event. We also do a lot of special events throughout the year. One of the big things that we brought to Frosty Drew over the last few years was the idea of hosting concerts or music-based lectures out under the stars. We don't produce a lot of light from it. We keep it very dark. And the idea is where we'll have a scientist who does a lecture with a musical troupe behind it that does a musical performance, and then a video expert that will do a video piece with it. And it has gotten very popular. This year, again, it's going to be all about the James Webb, and we're always adding new events. We're going from a position of being at Frosty Drew every Friday night to being at Frosty Drew as often as possible. And that's very important to us. So I believe that Bill really covered the light pollution thing very well. I don't want to talk too much about light pollution stuff tonight, but I did want to throw this out there because this is an issue. So Cherry Springs Dark Sky Preserve in Pennsylvania. It's roughly about 7.5 hours from here. And up until 2021, it was the closest dark sky preserve to the New England area. It is heavily visited by tourism from all over the place, but there's nothing there. There's not hotels, there's not beaches, there's not restaurants, there's not accommodations for people, so it becomes very difficult for the general public to really enjoy the site, and it becomes more of a destination for scientists. The left image here was taken by one of our astronomers at Cherry Springs. This right image was taken by myself using the same settings and the same camera in Integrit Park. Camera on the left slightly more out of focus, this is why the stars look a little bigger. You'll notice that it's almost the same. We have a little bit more light pollution where we are, but it's pretty close to Cherry Springs. That was 2016. Jump to 2022. The left is Cherry Springs. This is through a telescope. This is an image called Messier 110. Or 101, I'm sorry, and it is a galaxy that sits in the constellation Ursa Major. On the right, this is Charlestown. Light pollution has increased significantly in Charlestown, and this is with a lighting ordinance. It is happening here. It's happening in the community, and it's happening around the community. It's finding its way in. Bill had mentioned LED lights, and LED lights really are fantastic, but there is one problem with LED lights. And what it is LED lights emit light in broad spectrum. I'm not going to get too scientific on you here, but what it means is that you can't filter it out. No matter what filter you use on a telescope to try to block the light, it's present in every wavelength. And that's different in the way it was when we had sodium vapor lighting. So we could block all the sodium emissions lines in the spectrum and get away with it. It doesn't help you if you're out looking at the sky, but it does help you if you're actually working with a scientific goal in mind. But on a light pollution note, all the great explorers of our time, all the people that did amazing things, they all sat out under the stars and saw that view of the Milky Way, thousands of stars in the galaxy in front of them, and they said, that's big. What's out there? And they wanted a piece of that. By blocking the night sky, we're losing that. I meet less people now. I work in science. I work at Brown University, I work at Bryant University, in the very small science department at Bryant University, at Frosty Drew, I am constantly around people in science, and I'm hearing less and less every year people talking about being inspired by that view. And I feel like we're almost like the way we used to be, walking around with our heads down, looking at our phones instead of looking up at the night sky. So light pollution is a big deal. Now, sorry, that was my alarm telling me that I need to get everything ready for imaging tonight. I forgot to turn off my alarm. All right, so this past year, though, a really amazing thing happened at Frosty Drew. And this is it.
Over the month of October 2021, the Frosty Drew Observatory replaced its 21-year-old Meade LX200 16-inch Schmidt-Cassegrain telescope with a new Planewave CDK 600, which includes a 24-inch optical tube assembly and the L600 mount. This is the time lapse of the entire project, from removal of the initial telescope to completion of the install of the new Planewave CDK 600. The first step of the replacement process required removal of the existing Frosty Drew Observatory telescope, a Meade 16-inch LX200 Schmidt-Cassegrain telescope, which had been in the observatory for the last 21 years. Removal of the telescope had to be done in stages, with the optical tube assembly first, followed by the fork, and then the mount base. Once the mount base was removed, we were able to evaluate the existing Meade pier and decided that we did not have the correct specifications on the pier to accommodate the Planewave CDK 600. Though the pier was much heavier than we expected it to be, we were able to remove it successfully. Once the pier that was accommodating the Meade telescope was removed, it became clear that the original pier, which held the astrophysics 7-inch refracting telescope, which was the first telescope in the Frosty Drew Observatory, that pier was still partially in place, and due to the small openings and cabling requirements of the CDK 600 pier, or the Planewave pier, we needed to remove the old telescope pier from the pier foundation. We discovered that the original steel column was inserted into the wet foundation cement with the bottom open. The cement inside was higher than the outside surrounding plain foundation, and that required us to jackhammer and remove the cement from inside the steel column, and then cut the rest of the pier column out and machine the pier column down to a plain level surface. The cement of the original pier foundation was also not fully level and required additional grinding as well. Frosty Drew Observatory team members Mike and Derek worked diligently to get the pier foundation and the old pier column as level as possible. You see Derek holding a cardboard box, and the point of this was to prevent metal shards from flying all over the observatory during the grinding process. Once completed, the pier and the metal column were perfectly level and ready to accept the Planewave pier. The final step of this process required the filing of all machined edges to remove burrs or possible sharp areas that could damage the Planewave cables. We also had to paint those edges to prevent rust from setting in. Once the pier foundation had been properly upgraded and prepared for acceptance of the Planewave pier, we began to install the pier itself. Installation of the pier required precise leveling, alignment with the foundation, as well as alignment with the cardinal points of our location. Anchors were inserted 10 inches into the original pier foundation, then left to cure overnight with a high-strength bonding epoxy. The pier install occurred the night before the PlaneWave installation was to take place, and Frosty team members stayed over on site that night in preparations for the morning delivery of the new PlaneWave telescope. On Saturday, October 23rd, the new PlaneWave CDK 600 telescope arrived at the observatory at 7 o'clock a.m. First, we lowered the L600 mount into the observatory via crane and slowly attached it to the PlaneWave pier. Once attached, post-installation steps were required, which included switching the declination access limiter to the alt-azimuth position, and then installing the saddle to accept the PlaneWave CDK-24 optical tube assembly. Once we were satisfied that the L600 mount was ready to go, we began disassembling, balancing, and lowering the CDK-24 into the dome via the crane. Attaching the CDK-24 to the L600 saddle was the most difficult step of the day. It required very precise balancing and attachment of the CDK-24 in the L600 saddle, and we ran into a few hang-ups along the way. Though the hang-ups that we experienced were not outside of our reasonable expectations for the day, Frosty Drew team members Derek, Mike, Scott, Jessica, and Greg all assisted in performing the balance and attachment of the CDK-24, while Frosty Drew team member James videographed the entire event. This concluded the installation steps of the PlaneWave CDK-600.
That was a huge upgrade to the Frosty Drew Observatory. This telescope is a 24 inches of aperture. The old telescope was 16 inches of aperture. This is a cutting-edge telescope. It was made by a company called PlaneWave, and it uses a telescope design that currently has no flaws that are known yet. And it builds on top of the successes of every telescope that has come before it, including models like the Ritchie-Chrétien, which is what the Hubble telescope is based on, and the Schmidt-Cassegrain, which used to be in the dome. This telescope uses a direct drive mechanism in both the azimuth and altitude axis, which means that there are no gears, and it's just magnets that move the telescope around. This reduces damage from people holding it. It makes the telescope move very smoothly, and it allows us to track the sky at a fraction of a degree when we're doing our work and doing public outreach. If you haven't been to the observatory yet to see this new telescope, I highly encourage you to visit. It is an amazing device. With this telescope, we've been able to start stepping up a lot of our work that we do. This is an image we captured in June of Messier 51, the Whirlpool Galaxy. This is an interacting spiral galaxy where you have a smaller galaxy is merging with a larger spiral. This is 31 million light years distant. Though we captured this view in June, the light from this is actually 31 million years in the past. And this galaxy is 76,000 light years in diameter. Another object we've captured is Messier 63, the Sunflower Galaxy. We've captured all these with the new PlaneWave. This is a flocculent spiral galaxy, one of the few that are out there, where it looks like there's several spiral arms in this galaxy. There's really only two. And all of these blue regions are all areas of young stars that are still in clusters. They're young enough where they still haven't moved out on their own. What's fueling the star formation in this galaxy is a mystery. This is Messier 64, a Seyfert spiral galaxy. What you see here is a spiral that's not very clear, but you have that really dark dust lane over the top of it. It almost looks like a black eye. It's called the Black Eye Galaxy. And what you're seeing here are two galaxies that have recently merged. And the second galaxy is organized over top of the plane of the primary galaxy and hasn't fully settled in yet. And this is 17 million light years distant from us. Messier 65, part of the Leo triplet. This galaxy sits on almost on edge from our point of view. We look across the galactic plane. These galaxies are similar to the Milky Way galaxy. This is an intermediate spiral, which means that it is interacting with galaxies nearby. The next image I show you is one of the images that it's interacting with. And you'll notice that the plane of the galaxy is slightly warped. Messier 65 is directly interacting with Messier 66 as they're part of the same group, and they are going to merge. You'll notice that you've got a lot of, looks like dust around it, but these are stars that are getting flung into the outer halo of the galaxy by that interaction with Messier 65. Messier 82 is a galaxy that we did a lot of work on at Frosty Drew back in 2014 when there was a really large supernova event that occurred in that galaxy. It's one of our areas of research, and this was a recent image that we captured in March 2022 of this galaxy. This is a starburst galaxy. There is so much star formation happening in here that the entire galaxy has a red glow around it. And as all the hydrogen in the galaxy is being ionized by those young stars that are forming. This galaxy is 11.852 million light years distant, and I can tell you that very, very confidently because we're the ones that measured the distance at Frosty Drew. And then Messier 100. This was the commission image of the new telescope. We installed the telescope in October, and it became operational in February. And this was the image we captured that marked the telescope as fully operational. This is 55 light years away from us. It's 107,000 light years in diameter, or 55 million light years. And this is a face-on spiral. And right in the center, you got like that little blue ring right in the core. And that is a huge chunk of star formation that is being fueled by all of these satellite galaxies which are starting to merge into the galactic plane. And these are some of the things that we can see with that new telescope. Now, keeping the sky dark is important because looking at objects like this will not last if we don't have that dark sky. And I wanted to note, even though this is the last object I'm going to show you, Messier 109, this is the furthest galaxy that is in the Messier catalog. It's 83,500,000 light years distant. So even though we captured this image in early April, that view was from 83 million years ago. And this galaxy is twice the size of the Milky Way. Now, all of these images are part of a catalog called Messier, and one of the projects we've been doing at Frosty Drew since 2020 is to re-image the entire catalog of 110 objects. And the new telescope has made this very much a reality. If you come to Frosty Drew, you can learn a lot about what we're doing with this catalog, and you can see what we've done so far in the Science Center. A quick note about dark skies. Something that people don't think about with dark skies is they look at it as a restriction or a regulation or somebody telling you you can't do this. But there's another way to look at it. As I was saying before, the Cherry Springs, 7.5 hours away, is the closest dark sky park to New England. There's one now up in northwest Maine, in the middle of nowhere. Everybody comes to Frosty Drew because we're the darkest spot in southern New England. Charlestown is currently the darkest site in southern New England. And in all of New England, we're listed as the most accessible spot to see the Milky Way because you can drive right into the park. There's an observatory right there. And we're in a tourism community. We have accommodations to handle visitors. And they have other things they can do, like go to the beach during the day. Dark skies is one of the #1 thing on most people's bucket list. That 80% of Americans that don't see the Milky Way, it's on their bucket list. They want to see it. Every day we get at least 20 write-ins. When can I come and see the Milky Way? When's the best time? Everybody wants to see it. And we have visitors that come from Virginia. They come, and they don't go to Cherry Springs because they want to stay. They want a place where they don't want to sleep in a tent. Dark skies is a natural resource. And natural resources have always been the hub of prosperous civilization. They're exploitable. And this one is a natural resource that is in high demand right now. And Charlestown is so poised to exploit this. We have everything we need here today to bring that tourism community here. So, Frosty Drew, please visit us. You can check out our events online. And yeah, that's our youngest team member, Unity, setting up the telescope. So you'll see her if you come out to the observatory. She's a little rock star. She's a math genius. I ask you to talk to you about Occam's razor. So if you guys have any questions, now is the time.